Hi, in this video, we'll go through the steps to perform an extended period simulation in EPANET. We'll use example 2 from the tutorial document that is made available to you as part of the course package. The document also contains all the relevant details about this problem, such as inputs and other constraints. So make sure that you have it before you start this problem. As you can see that we have two pumps in the system, although they look like three pumps, but this is the first pump, and this combined is the second pump, and this pump, which is shown with pipes 7 and pipes 25, it has two service levels. That means at any given time only one of these service levels is operational, and that depends upon certain conditions that we'll take into consideration while designing this network. Additionally, this has three tanks, and we are required to design these tanks in the network also, and these have certain water levels in the starting, and as the simulation goes on during the entire day, the tank water levels fluctuate depending upon what the conditions and the requirements are. We have 25 pipes in the system and 13 junctions to connect these pipes, and we need to design this network to run for an entire day, that is 24 hours duration. So now let us start with the example. This is the first screen that you'll see when you start EPANET. The first thing that we have to do is set the default values. As you can see here at the bottom, the default flow rate is in gallons per minute, but for our example, we need the flow rates to be in million gallons per day. So we can go to project, go to defaults, and go to hydraulics. We can change the flow units here using the drop-down menu. We have a range of options. In this case, we need it to be million gallons per day. And we can also decide what type of head loss formula that we are using. In this example, we are required to use the Hazen-Williams formula, so this one is okay. And you can keep all other values as the default values. Second thing, we go to properties. Here you can fix certain values, like if the pipe diameters are fixed at a certain number, then you can assign the default value to that. Similarly for pipe lengths and pipe roughness. But in our case, these things are changing, so you can keep them as defaults. And finally, the labels. It is a good idea to add some prefixes. So let us add a prefix J to each junction, and I'll add a prefix P, which means a pipe, and I'll add a prefix PU to designate a pump. So these prefixes will help me understand which one is a junction, which one is a pipe, and so on. I click OK. And the second thing is I have to go to analysis options. Then I move to the browser window here, and I need to fix the times. So since I'm interested in doing an extended period simulation or an EPS simulation, I want the total duration of the simulation to be 24 hours. So EPANET requires the inputs to be very specific. So if you enter it as just 24, it may give you an error, or it may not give you an error, but still end up doing wrong calculation. So be very careful with the formatting of the numbers that you provide. And in this example, we want the calculations to be done at 1 hour interval. That is okay. And later on, you'll see something called global demand factor, and we want the simulation to start at 12 a.m. and rest everything looks fine. Next, we go to the view menu here, and then to options, and we go to notation and check the display node IDs and display link IDs. So these will assure that when you design the network, those labels will be displayed beside them.